we have what is the molecular geometry of IF5? So, with this, it seems relatively simple because it's only asking just pick one of the A, B, C, or D, right? But in order to even answer this question, we need to first draw our Lewis structure. So there is quite a bit of steps involved, because to find the molecular geometry, we need to know what this thing even looks like, and we find that out by its Lewis structure. So let's find out how many electrons we're working with. Luckily, IF5, they're all halogens, all on the 17th column, so they all are going to have 7 valence electrons. So there's 6 atoms in total, 1 iodine and 5 fluorines. So in total that's 6. So 6 times 7, we have 42 electrons to work with. Alright. So now, considering that iodine is the only one that's different from the group, we're going to actually put that in the middle. Okay. Okay. So we have I, and we're going to now 2, 3, 4, and we're going to now add the octa one 5. Okay, because iodine is one of the many atoms that can break the octet rule. So that's what we've done here. So iodine currently is actually sharing, as we count here, 1, 2, 3, 4, 5, 6. Whoops, sorry. If you only count individually, 1, 2, 3, 4, 5. It's sharing currently 5 of its 7 electrons. So to make up for it, is also just going to add 6 and 7. So I want to make it a little bit further away. It's going to have that. So it's really going to be surrounding itself in total with 4, 6, 12 electrons in total. So it is quite a full molecule. Fluorine, on the other hand, let's start with this one. It's sharing one of its 7, so it's going to be 2, 3, 4, 5, 6, 7. There we go. Same with this one. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So if we were to count the amount of electrons there, we would actually see that we should have 42, because that's 40 and then 2 more. Because I just count based on what's surrounding the fluorines. We don't really count the iodine one because that already includes it. So it's going to be 8 times 5 because there's 5 fluorines, and the 2 more extra on the iodine. So that would be the Lewis dot diagram. Okay. So then with that being said, we then have to now make sure that we have the correct form by seeing this formal charge. So iodine in the middle has 7 valence electrons, and right now, as you can see, it has only 2 electrons to itself, that one lone pair, and it's sharing 2, 4, 6, 8, 10. So conveniently, that's 2 plus 5, that's 7. So this checks out. And for the rest of the fluorine surrounding it, it really is just going to be 7. It has 6 by itself, and it's sharing 2 of them. And so both have 0. So this would actually be what the theoretical Lewis dot diagram would look like. So now with that being said, we need to identify its shape, starting with its hybridization. So the way you find a hybridization is to find out how many things are attached to it, whether it be lone pair or bond. Doesn't matter which type of bond, just a bond, period. And if you count, we have 1, 2, 3, 4, 5, 6. So 6 things are attached to it, okay? So that's going to be S, that's 1, 2, 3, 4, sp3, 5, 6, d2. You see, if this had a power, it'd be to the 1, so it's 1 plus 3 plus 2. It should add up to 6. So that's how you would write it there for the hybridization, meaning that this is going to be an electron geometry, okay, of octahedral. But this is the electron geometry. So if you picked A, that would be wrong. We need to then go ahead to see now what type of things are attached to it. We say that it's 6 based on how many things in general, but now what type? You have to split it into how many bonds, which is 5 bonds, and how many lone pairs, which is 1. Using this information now we can find its molecular geometry. Now for this I do not have it memorized, but it's important that you do if the course asks you to. But if you look at this, if you look at the Vesper theory, we have here, when it's 6, 5, and 1, it looks like this. Square pyramidal is what it's called. So exactly, as the picture shows, the iodine would be here, the lone pair would be down there, and everything else would be above, kind of like a square. And then it will form the pyramid with the last fluorine sticking up. So these ones would be like pseudo 90 degrees, and then there'll just be that lone pair bottom there. So if you look at it from a flat plane, it'll look kind of like this. The lone pair is down there, and that's what it's looking like. So this is what we call a square pyramidal. So like I said, this is now the molecular geometry. Octahedral would be its electron geometry, so that one will be wrong. So looking at that, when we look at these choices, the correct answer is actually going to be B. Okay? That will be the molecular geometry of iodine pentafluoride. Okay? There we go. They gave us a Lewis structure. And then they have the steric number, which is, they got a 6, which is what we're doing in terms of calculating the hybridization. And you can see here that based on this chart, because one of them is going to be a lone pair, we have the name square pyramidal. So the correct answer is indeed B. This is correct. So now look at question number 9. Okay.